This is Algebra Lesson 7-2, Solving Systems by Substitution. Substitution is when you choose one value or expression and put it in place of another value or expression. By replacing one variable with an equivalent expression containing another variable, you can create an equation that contains only one variable, and thus you can solve it, just like we did in Chapter 3. This is what's called substitution. Now, you should have paid attention to the last lesson when you did graphing. Not every equation can be easily solved by graphing. All equations can be solved by graphing, but sometimes they're not easy to do. Graphing is cumbersome, and it may not be the best or most efficient method at a particular moment. If a solution doesn't land exactly on a coordinate point, it may be very difficult to determine what fractional point that happens to be. And this is where substitution comes in, because it makes it much easier to solve an equation. Okay, let's take a look at this system of equations. I will walk you through how to solve a system of equations by substitution. In problem number 1, we have two equations. Y equals 3x and 2x plus 4y equals 28. The first thing you always want to do when you use substitution is you want to get one equation solved for a single variable if it isn't already. If I look at these two equations, it's obvious to me that the very first equation is already solved for y. So I have equation 1 here and equation 2. Equation 1 is already in the form of y equals 3x. It's already solved for a single variable, or the variable y. So now all I need to do is in equation 2, every time I see y, I'm going to plug in 3x. Every time I see a y, I'll put in a 3x, because that's what it says that y is equal to. So in equation 2 here, I have 2 times x plus 4 times y, but remember, y is equal to 3x, so I will plug it in a 3x in place of y, and that equals 28. Now that entire equation is in terms of x. There's no y's in this equation at all. So now I look at this and I have 2x plus 4 times 3 is 12x equals 28. 2x and 12x is 14x. 14x equals 28. To solve for x, divide by 14. So x equals 2. That was very nice and simple. I now know that x equals 2. Once I know that x equals 2, I can substitute back into my first equation. My first equation says y equals 3 times x. So y will equal 3 times 2, which means y equals 6. So my solution to this equation is 2, 6. My solution to this system of equations is 2, 6. Solved by substitution. Now I should probably check and make sure I'm right. To do that, all I have to do is plug 2, 6 back into this original equation and check and see if it makes a true statement for both of them. So if I plugged in 2, 6, I have 6 equals 3 times 2. That checks, because 6 definitely equals 6. Here, 2 times 2 plus 4 times 6 is supposed to equal 28. Well, 24 plus 4 is 28. That checks as well. So 2, 6 is a legitimate solution to this system of equations. Solved much faster than graphing. Let's look at problem number 2 here. We have two equations again, equation 1 and equation 2. Equation 1 is not solved for a single variable, but equation 2 is. Equation 2 already has x equals y plus 1, which means now every time I see a y in equation 1, every time I see an x in equation 1, I'm going to replace it with y plus 1. So this will move in for that right there. So let's take a look at this. In equation 1, it says x, which is actually y plus 1, plus y equals 5. All I did was plug this into this equation right there. So I have y plus 1 plus y equals 5. Y plus y is 2y plus 1 equals 5. Subtract 1 from both sides. 2y equals 4. Divide by 2. Y equals 2. So I now know that y equals 2. The second equation is already solved for x, because it tells me right here X equals y plus 1, so x is going to equal y, which is 2 plus 1, so x will equal 3. So my solution to this system, written as a coordinate pair, because that's how you always write your solutions unless it's a word problem, is going to be 3, 2. Again, I could check to make sure it makes sense. If I checked it in here, 3 plus 2 does equal 5. And here, 2 equals 3 equals 2 plus 1, so it checks there. So what my solution does indeed check. Now, not all equations will be written in terms of a single variable. Okay, if you notice these two equations, neither one of them is written for a single variable. However, if I look at this, I have two equations, equation 1 and equation 2. Equation 1 could easily be written for the single variable y, because there's no coefficient, there's no number here in front of y. So notice how there's no number, which basically means there's a 1 there. So I wouldn't have to divide anything to solve that for y. So I'm going to take this first equation here, and I'm going to solve it for y. So y would equal negative 2x plus 13. I just moved the 2x to the other side by subtraction. Now in equation 2, every time I see a y, okay, right here, I'm going to plug in 2x plus 13. So here we have equation number 2. I have 4 times x minus 3 times y, but y is negative 2x plus 13, and that is going to equal 11. Now here's where you have to be very careful, especially with your negative signs. If it helps, it would probably be to your advantage to do this. That way when you run the 3 through, you actually run a negative 3 through, and it gets through with all the signs in the right places. So here I will have 4x. Negative 3 times negative 2x is positive 6x. Negative 3 times positive 13 is negative 39. And that will equal 11. 4x and 6x is 10x minus 39 equals 11. So I will add 39 to both sides. That means 10x equals 50. Divide by 10. X equals 5. And I have that x equals 5. Now I can solve for y. I can put it in any equation I want, but it's probably easiest to put it back into this equation right here because it's already solved for y. So that's exactly what I'm going to do. I'm going to plug in x equals 5 into this equation up here. So I will have y equals negative 2 times 5 plus 13. So y equals negative 10 plus 13. So y equals 3. So the coordinate point that is the solution to this equation is 5, 3. And again, if you're not sure, you could plug it back in and check it to make sure that it is accurate. Let's look at equation number 4. I could solve either one of those two equations for y because I have a single y here and I have a single y here. I think it might be easier to solve for the second equation because the first equation has it in negative y, and I'd prefer to solve for positive y, so I'm going to change this and solve for y. So y will equal negative 2x plus 10 because I have to move the 2x to the other side, and to move it to the other side I have to make it negative. So now every time in equation 1 I see a y, I'm going to put it in negative 2x plus 10. So here's an equation 1, I'm going to have 4 times x minus y, and y is negative 2x plus 10. Make sure you have that parenthesis with the negative on the outside of it, and that equals 5. Be very careful running this negative through. It might be helpful to put a plus negative 1 on the outside and run a negative 1 through this parenthesis. If that keeps you from making a mistake with one of your negative signs, I would highly suggest you do that. So I have 4x. Negative 1 times negative 2x is positive 2x. Negative 1 times positive 10 is negative 10, and that will equal 5. So this becomes 6x minus 10 equals 5. Add 10, add 10. 6x equals 15. Divide by 6. x will equal, 15/6 is divisible by 3. 3 goes into 15 5 times, 3 goes into 6 twice, so it's 5/2. Okay, or 2.5, whichever way you want to look at it, doesn't matter. Okay. So my solution to this ordered pair will be when I plug in 5/2 back into y. And yes, you can get fractional answers, and those are perfectly acceptable. Don't think that if you get a fraction, it's wrong. If you get every problem to be a fraction, it's probably wrong. If you get a couple of fractions now and then, you're probably okay. Okay, so we're going to plug this back in. So y will equal -2/1 times 5/2 plus 10. That's what it tells me to do. So since I'm multiplying, this can cancel with this. So I'm going to have y equals -5 plus 10. -5 plus 10 is y equals 5. So my solution to this system of equations is 5/2 or 2.5 and 5. If it's a fraction that is improper, you can leave it as improper. You can change it to a mixed number, or if it's a terminating decimal, you can change it to a terminating decimal. If it's not a terminating decimal, leave it in fractional form. We've had that discussion before. Okay, let's take a look at some word problems. The sum of a number and twice another number is 13. The first number is 4 larger than the second number of the numbers. Okay, not too hard. I have two numbers, so I'm just going to let x equal the first number, and I'm going to let y equal my second number. Okay, it says the sum of a number and twice another number. So the sum of a number, the first number, the sum means add, and twice the second number, so 2 times the second number, is equal to 13. Remember, is in math means equals. That's my first equation, not too hard. The second number says the first number is 4 larger than the second number. So the first number, which is x, is means equals 4 larger than the second number. So the second number plus 4. 4 larger than the second number. So here's my first equation, here's my second equation. The second equation is already solved for x, so that's nice and simple. So every time I see an x in equation number 1, I'm going to put in y plus 4. So here in equation 1, I have x, which is actually y plus 4, plus 2y equals 13. So y and 2y becomes 3y. 3y plus 4 equals 13. Subtract 4. 3y equals 9. Divide by 3. Y equals 3. Now that I know that y equals 3, if I substitute that back into the second equation, x equals 3 plus 4, so x equals 7. Now, because this is a word problem, we're not going to answer it in a coordinate pair. It's a word problem. You have to answer it in actual words. So what are my numbers? My numbers are I'm going to list them in order. X is 7, 7, and 3. So there's my numbers. They're not hard if you can get to the equation form. If you can get to this portion right here, you can solve it. If you can write the equation, you're halfway home. Let's take a look at another problem. Down here. A youth group with 26 members is going to the beach. There will also be 5 chaperones that will each drive a van or a car. Each van seats 7 persons. Each car seats 5 persons, including the driver. How many vans and cars will be needed? Okay, so here we have. We need vans and cars. You can either put V for van and C for car, or X for van and Y for car. I don't care. Just make sure you define the variables. I'll make it easy. I'll like V equal vans and C equal cars, just because it's easier for people to follow. Okay, a youth group with 26 members. So we have to do equations based on that. There will be 5 chaperones that will each drive a van or a car. Okay? So Since 5 chaperones will either drive each a van or a car, and that's what I'm looking for is right here, that gives me an equation all by itself. Okay? The number of vans plus the number of cars has to equal 5 because I only have 5 chaperones that can drive. Nobody else can drive, so the number of vans that I have plus the number of cars that I have can only equal a total of 5. Okay, so that's one equation. One equation is based on how many vans and cars I have. The second equation is going to be based upon how many people each one of these vehicles can seat. A van can seat 7 persons, including the driver, and a car can seat 5 persons, including the driver, which means 7 people total in the car with the driver and 5 people total in the car with the driver. So 7 people per van plus 5 people per car, and I have a total of 26 members plus 5 chaperones. Okay, so 26 plus 5 means there's 31 total people. Okay, 26 people plus the 5 chaperones equals 31 total people. 31 total people have to fit into the cars. So now I have 2 equations. I can solve either equation 1 or equation 2 for my variable. I'm just going to take equation 1 and I'm going to solve it for v. So v is going to equal negative c plus 5 or 5 minus c, however you want to write it. So in equation 2 here, I'm going to have 7 times negative c plus 5 plus 5c equals 31. So 7 times negative c is negative 7c plus 35 plus 5c equals 31. Negative 7c plus 5c is negative 2c plus 35 equals 31. If I want to solve this, I will subtract 35. And I get negative 2c equals negative 4. Divide by negative 2. C will equal 2. So now I know I need 2 cars. And if vans plus cars, way up here, vans plus cars equals 5, you should be able to do that pretty quickly, process of elimination. What plus 2 equals 5? Well, 3. So the number of vans is going to equal 3. So we will write this down as a word problem. We will need, as it says, how many vans and how many cars will be needed? 3 vans and 2 cars will be needed. We always write our word problems in a complete sentence. And there you have it. Substitution makes it so much simpler. It's a little bit faster. You don't have to graph, so it doesn't take as much paper. And if you get fractions, it ends up being a much more accurate answer.